So basically week 5, as you kind of saw with last week also, we started grouping chapters together, because now that we're getting into these, um, some of these chapters, we're not actually doing the entire chapters, or the chapters are really small. So we are doing, maybe a couple sections from each chapter. So that's why we're grouping chapters together. So you've got chapters 7 and 8 that we're actually doing this week. And chapter 7 and 8 actually talk about normal distribution. So you guys did binomial distribution last week. This week, we're getting into normal distribution. And you've actually had a little bit of an introduction to normal distribution in the previous chapters, because you talked about z-scores when we were talking about measures of position in chapter 3. So they introduced z-scores. And in that same chapter, they actually also introduced you to the empirical rule. So when they discuss, the Chebyshev theorem, they also talk about the empirical rule. So what happens with normal distribution is, we are looking for calculations or things that are normally distributed. So you can kind of think about, the average height for an adult male or females, weight. Some of these quantities are normally distributed. And what we mean by normal distribution is, they fall into kind of that bell curve or the Gaussian um, distribution kind of thing. So a lot of these, and you will see different examples, as you're going through your homework assignments and all of those things. But basically what I want you to keep in mind is, when we're talking about these z-scores, because you will see as we get into this discussion for the normal curve or the normal distribution, you will see that when we talk about z-scores, remember z-score is just telling you how far away from the mean is your data value going to fall. So basically the z-score is just another term for standard deviation. They just want to know how far away from the mean your data value falls. So if we say, the average height of an adult female is, I honestly don't remember the number, but it's like 5 feet 6 inches or 5 feet 4 inches, something like that. And then if you go to different cultures or different parts of the world, that average height will change, because if you think about, Asians, they're supposed to be shorter people, so that average height would be less. So I'm just kind of going in general with, America for now. So I think it's like 5'4" or 5'6", somewhere in there. So if we think of that as our average, then, the idea is how many people are above average and how many people are going to fall below average. And so that z-score basically kind of tells you if you're below the mean, then, of course, your height is going to be less than 5'4". If you are above the mean, then your height is going to be more than 5'4". And then, it just kind of helps you calculate what percentage of people fall, within the first standard deviation. So, maybe from a height of 5'2" to 5'6", what percentage of your population will fall in that height range? If we go a little bit beyond, 2 standard deviations, what percentage will fall, and 3 standard deviations? So that's kind of what they talked about in the empirical rule. And then, as I said, they will bring that concept in again when we start talking about normal distribution. So let me just show you some basic things here. Let me share my screen here with you. So I'm just actually showing you the handout from you. And remember, you have these handouts in D2L available to you. So, they kind of get into a little brief discussion over here in, what happens when you are looking at, a normal curve where both the curves have the same mean, but then they have different standard deviations. And let me make this a little bit bigger. So you can see they have the same mean. So, their peak or the center part of the normal curve is right at the same point, but based on the standard deviation, you can see if your curve is going to be more, vertically oriented, or is it going to be, starting to get a little bit flatter. So this is kind of what happens with the same mean, but different standard deviations. Or you can have the same standard deviation on your 2 different data sets, But if they have two different means, then you can see how the two curves are going to be in different positions. So, anytime we're talking about the normal curve for the data set that you are working on, you are going to need to know what the mean and the standard deviation for those data sets is going to be. So, that's definitely something you will be getting into in this chapter. And they kind of go through the properties of, the normal distribution. What are you kind of looking at? One thing you have to keep in mind when you're talking about, things being normally distributed, your mean, median, and mode, all of them are going to be the same exact value. So they will always be equal to each other. So if you remember again from what you guys did in chapter 3, depending again on your data set, your mean, median, mode can be 3 different values. And we actually saw some of that example, when we did our class activity for chapter 3. So with data sets that are normally distributed, that means your mean, median, mode are all going to be the same exact value, which also means that your normal distribution curve is going to be unimodal, which means you will only have one mode instead of having multiple different modes, again, like some of the examples you had seen. One of the other things you want to keep in mind is the symmetry that happens with the bell curve. So it's symmetric about the mean, which means your mean kind of breaks your bell curve into 2 equal halves. So, the idea is if you were to fold that bell curve around your mean, the 2 halves of your curve would, be symmetrical. So they would be exactly identical when you fold them. And symmetry is going to play a big part as you guys go through your calculations and stuff for this section. So you will see a lot of times we actually use that idea of symmetry to help simplify some of the calculations we do. Of course, one of the other things you want to keep in mind is that this is a continuous curve. So, as you can see in the graphs also, these will all be continuous curves. There are going to be no holes or gaps in your curve over here. Now, another thing to keep in mind is that the curve never touches the x-axis. So you will always see, a little bit of that gap at the end. You will see that your, the tail of your curve will never touch the x-axis. So we always kind of leave that little space in there. One other thing you want to keep in mind is that the entire area under the curve is at 100%, or, in decimal form, we would say the area under the curve is equal to 1. Because, we normally write the percentages as decimals, but in percent that would be 100%, or in decimals that would be equal to 1. Now, the empirical rule that I was talking about that you guys saw in chapter 3 actually kind of breaks this down. So remember, your mean, median, and mode are going to be right here in the center. So that's your mean. And again, I'll make this guy a little bit bigger so you can kind of see that. Okay, so mean right in the center. And then when we go 1 standard deviation to the left and right of the mean, so that is going to be, 1 standard deviation below and above the mean. This is where we say approximately, this is going to be 68% of your data set. So again, if we were talking about, the height for adult women, then 68% of those women, adult women, will fall within that 1 standard deviation. So like I said, if you think the mean to be at 5 feet, 4 inches, and let's say the first standard deviation is at 5 feet, 2 inches. So this guy would be 5 feet, 6 inches. So then we can say, 68% of the adult female population in the US is going to be, between this height. Now, of course, you can see they are giving us these decimals of 0.13 and 0.13. So technically this would add up to, 68 point, what is that, 26%? But, normally we just go with 68%. If you go out 2 standard deviations away from the mean, so below and above the mean, so that would be this entire area of the curve, then that is approximately 95%. And then you can actually, I wrote over it, but you can see those numbers right here. So you can see within 1 standard deviation, it is 68%. Within 2 standard deviations, it is 95%. And then within 3 standard deviations, if you go out 3 units, above and below the mean, that's going to be approximately 99.7. So you will see we're not quite at 100% by the time you go out to 3 standard deviations. And that's because you still have a little bit of this tail area left over here, you will see. And that is where actually that remaining percentage comes from. So you can see they're kind of breaking this up into 0.13 and 0.13. But since we're using rounded numbers, that technically we actually count it as 0.15, because we're rounding up our answers. But if you go with the exact numbers that this little chart is showing you, then it's going to be 0.13. So it's actually the entire area under the curve that adds up to 100%. But like I said, if you're only going out to 3 standard deviations below and above the mean, then you're going to be at a little under 100% at 99.7. And as I was mentioning, these are going to be the values that, are definitely going to come into handy when you're doing these calculations. They ask you to find out the percentage, what data value falls within, whatever the Z-score they give you. Those would be the calculations you would have to go through. So again, I highly recommend you guys to look through the video lectures, read the handouts, maybe look at a couple of the examples that I have, because if you try to, jump into this head on, and if this is something you have not done previously, it will take some time to, understand if you try to do it on your own. But if you watch the video lectures, you look through the examples, it will definitely be a lot easier for you to understand. And they're actually just showing you the comparison between what happens when you have a normal distribution curve and when you have, a distribution that is positively skewed or negatively skewed. So you can again see in a normal distribution, your mean, median, mode are all going to fall in the center. But then depending on if it's negatively or positively skewed, you will see how you are looking at your mean, median, and mode in 3 different positions. So of course, we are discussing the normal distribution over here. So one other thing you will see is, if you're doing application examples, your mean is going to be some number, your standard deviation is going to be some number. A lot of times what we do is we convert our normal distribution into a standard normal distribution. So that means, we're equating our mean from, whatever it might be to a 0, and our standard deviations into, +1, +2, +3, or -1, -2, -3. So this is actually where that idea of the Z-score comes in, and this will be a formula that's familiar to you from your previous discussion in chapter 3. So this is the Z-score formula you will be using, and this basically helps us convert our standard deviation, our normal distribution into the standard normal distribution. And normally we actually use this table for our normal distribution over here. And this table actually helps you come up with the area under the curve. And by default, the way the table is set up, so it's got the 2 pages for the positive and the negative Z-scores here. So by default, whatever your Z-score comes out to be, it gives you the area to the left of that Z-score. So, if you found a Z-score somewhere here and you look under the table, that area is going to be all the way till that tail on the left-hand side. So it always gives you the area on the left of your Z-score. So your mean, which falls in the center of your normal curve, where you see the 0, that actually breaks up this normal curve into, remember we talked about symmetry? So the left-hand side is going to be 50% and the right-hand side is going to be 50%. So you will see right at the Z-score of 0, 0, completely 0, 0, it is 0.5 and then 0, 0, 0, because that's your 50%. You can actually also see that here on the negative side. So you've got negative 0.00 with, again, more zeros at the end. And you will see that also gives you an area of 50% or 0.5. So again, the mean breaks up your normal curve into two halves. You have 50% on the left, 50% on the right. And then as you can see, when you get into these positive z-scores over here, all of these numbers are larger than 50% or, larger than 0.5, because now you are looking at all the z-scores that will fall on this side of the curve. If you look at these negative z-scores, over here, you will see all of these numbers are smaller than 0.5, 0, 0, or smaller than 50%. And that's because all of these z-scores, fall below the mean. So that's a good way to keep track if your calculations are correct or not, because depending on did your z-score fall below the mean or above the mean, you know what your area should look like. Anything above the mean has to be larger than 0.5. Anything below the mean has to be smaller than 0.5. So, those are some of the things that you can use to kind of keep track of. And that is where this first section gets into. And it's doing it in a more generic sense, just to get you, in the habit of finding the z-score. So they will have you find z-scores, below the mean, above the mean, maybe in between two numbers. So that way you get a good chance to practice with this. So this will be something I definitely want you guys to, get comfortable with and practice. But we're going to do a little activity today to kind of get you into this whole process of, working with the z-scores and kind of using them and the normal curve to help us come up with, an answer for this activity here. So let's take a look at this, guys. So this one is talking about, a factory that is making bowling balls to, is trying to make 15-pound bowling balls. They have a shipment of 10,000 balls that they have to send. Balls that are going to be less than 14.9 pounds are considered too small. So, it's kind of that quality control thing. They want to make sure they are going to be as close to 15 pounds. Anything less than 14.9 is going to be unacceptable. So they want to make sure they are making proper bowling balls without having to test, obviously all 10,000 of them. So assume that the weights of the bowling balls follow a normal distribution. And this is something you will see even as you guys go through examples, from homework. They will always tell you if a data set is normally distributed. Because, if they don't tell you that, you cannot make the assumption it's normally distributed. So always look for that keyword, it's normally distributed, or, is normal, something with that reference to being normal. So that's how you can use the normal distribution to do those calculations. So they're telling you the weight of the bowling balls follow a normal distribution. So the factory has randomly selected 3 samples from this 10,000 that they are manufacturing. And they want to test this to see what the weight comes out to be. And based on that, can we make the assumption that all 10,000 are going to be within that weight range? And here are the samples. So they've got 3 different samples, and each sample, as you will see, has 10 balls, right? If you look at those numbers. So based on these samples, determine if the factory is sending out a good shipment or not. Your decision needs to be made using z-scores and the normal curve chart. And then, of course, they're talking about showing your work and justifying your reasoning. So you have all the weights over here. Now, remember, they said anything that falls below 4.9 pounds is considered to be too small. So they would not include those balls in the shipment. So it's got to be anything, of course, which is going to be between 14.9 and, 15 pounds. But then that also begs the question, what happens if the weight is a little bit higher than 15 pounds? Because, if it's going to be lower, it can be higher. Also, the first thing I want you to think about, as you can see in this example, they're not really telling us what the mean and standard deviation is, but they've given us enough information that we should be able to come up with that on our own. So looking at this, and I will actually share the link to this page so that way, if you want to read the instructions over again, you should be able to. So I'll send this through your Zoom chat, the link to this document here. So you should see that coming through. So just read through the instructions one more time and tell me, what do you think the mean and the standard deviation should be for this bowling ball example?
Do we have to find the mean and standard deviation for the sample 1 column, sample 2, and sample 3?
So no, you don't have to do it that way, because remember, what is the ideal weight they are hoping for these bowling balls?
15 pounds.
15 pounds. So what do you think that would be in terms of our mean and standard deviation?
So are we supposed to like not do like a traditional calculation for the mean? We just kind of eyeball it or guess?
No, you're not eyeballing it, because think about this again. If you are the manufacturer, you are sending this shipment of 10,000 balls, right? Bowling balls. And they're telling us that it's got to be 15 pounds, and anything which is less than 14.9 pounds is going to be too small. So if you had to pick, and this question is for all of you, not just Lola, but if you had to take your mean weight, what would it be for all of those 10,000 balls?
I'm assuming 15. Is that
Yeah,
right?
exactly. Right? Because that's the ideal weight you want your balls to be at, right? So you want the mean to be 15 pounds. Very good. All right. So now think about, again, the information is given to you right there. What do you think the standard deviation? Because remember, standard deviation is basically how far away from the mean you can be. So what do you think the standard deviation would be for the balls to still be acceptable, in the weight range, and to be beyond acceptable? So what do you think the standard deviation for this example will be?
In the problem, it says that if it's less than 14.9, then they won't send it. Like it's considered too small.
Right.
So like, would you say the standard deviation is 0.1?
Perfect. Very
Okay.
nice. Yeah. Crystal, what were you going to say?
I was going to say 0.1. I was just kind of guessing out loud.
Yeah. Yeah, no, very good. So I am actually going to send you this link over here for the, you know what, let me change this to editor, because otherwise it will not let you guys type in here. Alrighty, so again, I'll send this through our Zoom chat so you guys can get into the Google Sheets. So yeah, very nice. So our mean is going to be 15 pounds, and your standard deviation was basically 15 minus 14.9, right? Because that tells you what the standard deviation can be, which comes out to be 0.1. So I've actually given you the Z-score formula over here.
When I click on the link, nothing pulls up for me. I don't know if I'm doing.
It's not open for you?
I don't know.
Both of them, or just the Google Sheets?
Both of them. Even this third one, I'm trying to click on.
Do you want me to email it to you, Crystal?
Yeah, that would be great. I'm not sure if I just got a new computer, so I don't know if it's something that.
Me too.
Can you email it? Yeah, mine's not working either.
Elijah,
Oh,
yours
okay.
is not working.
Yeah.
I wonder why. Okay, so I'll send it to your ames.edu Okay, so that's for the Google spreadsheets, and let me get for the Word document here. Alrighty, so I just sent that email to your ames.edu email address, and hopefully you guys can get those links. Okay, so what I am actually going to do is I am going to put you in breakout rooms, and let's see what your z-scores comes out to be, and you can break it down according to, you know, what you think that, and then I'll show you actually how to do the normal curve, because that takes a little if that's something you haven't done it before, then you know you kind of have to work around it. Okay. So since there are, you know, 5 of you, I'm gonna have to do a group of 3 and 2. So you should see your messages coming through. All right, so Crystal and Jacob, you guys can work on sample 1. And I would say the first 5 from sample 2, so that way you guys can do equal, you know, shares. So sample 1 and the first 5 numbers from sample 2.
And we're just putting this on the on this group sheet here.
The Google Sheet, yeah. So just, you know, you can discuss what your z-score should be and start entering those.
Okay.
Okay, so we're just doing the z-score calculation.
Z-score
Yeah.
for now, and then I'll have to actually show you how to do your normal curve after that.
Got it. Okay.
Yeah.
Is that
All right, guys. So you are working on calculating the z-scores for sample 3
Oh, okay, cool.
and the bottom 5 numbers of sample 2. Since you are 2 groups, I'm breaking it up into 15 numbers each. So again, sample 3 completely, and the
Okay.
bottom 5 numbers from sample 2.
Okay. Before you leave, so we're gonna find the z-score for all of them. Is that all we have to do, or
For
do
now,
we?
because I will actually have to show you how to do the normal curve, because if that's something you have not done in Excel or Google Sheets before, then it takes a little bit of understanding on how to create that table. So I will show you how to do that, and then you can come up with your curves after that.
Okay, sounds good.
Yeah, good luck.
Thank you. Okay, cool. So I was thinking, since there's 15, we can.
She'll let us know. Can you let us know if I'm seeing minus, but I don't know if that's correct, honestly. Is it supposed to be minus, or is it supposed to actually just be positive?
Crystal, do you know the answer to that?
Minus
I mean,
I want to say
the
it should
reason
be
the reason why I could think it could be minus is because the less of the has a lesser probability of 0.46. So
I want to say from the homework, yeah, like I've had when like calculating the z-scores, there have been the negative. But I'd have to go like look at my, let me look back.
Yeah, because
I wanna
remember, it's the idea of, are you above the mean or below the mean, right?
right,
If you're above-
that's my
yeah.
only confusion. Yeah.
Right. If you're above the mean,
So
so
it
if the
would be-
number is larger than 15, you know, you get a positive z-score. But if your number is smaller than 15, you get a negative z-score, because that's telling you you are, you know, less than the average weight you are looking for.
Right. That makes sense.
Okay.
Thanks for
good.
clearing that up.
Yeah, no problem.
start with the sample size 2 and do those 5.
And it is possible to have a z-score of 0. That would technically equate to 0.5.
Mhm.
Yeah, because that means you're right at the mean, right?
Right. Okay.
Very good. How are we looking here, guys?
Pretty good.
All right.
Good so far. We just we have our formula, which is x minus average divided by standard deviation.
Mhm.
And then since there's 15, we're just gonna kind of pass the work. Like, so we're gonna do 5 problems each.
Yeah, I think that's a great idea because that way each of you have, same number of problems to work on and you get to practice individually also.
Yeah.
Yeah, and if there's any confusion, you can definitely have each other help you out also. So whatever you guys are comfortable with.
Okay.
Yeah, perfect.
Oh, that's so strange.
So one thing I wanted to just kind of let you guys know that remember, depending on your data value, if it's larger or smaller than the mean, you can have positive or negative z-scores. Just because, if the number is larger than 15, you will have a positive z-score because that means you're, the bell curve, you're on the right side of the mean. If the data value is less than the mean, so smaller than 15, you will get a negative z-score because that means you're on the left side of the
Mhm.
mean. So you should see both positive and negative z-scores in your data set.
So if the what are you, hold on. Okay, wait. So if the number for x is more than 15,
You will get a
then-
positive answer.
okay, but if it's less than 15, we should expect it to be negative.
That's correct, yeah.
Okay, cool.
I don't think that I'm doing this right because my numbers are not coming out anything like this.
Okay.
Okay,
So
what are
you said to
doing?
do x minus the average over the deviation. So I would do 14.993 minus the 1.5 over the 0.1.
Not 1.5, just 15.
Just 15. So
Because remember, we're keeping the mean as that 15 pounds.
oh, I didn't see. Okay. Yes, I see now.
Okay.
Yeah, I think you just got the mean wrong, honestly. but
Yeah,
once-
okay. Yeah, I see
yeah.
why I was messing up.
Oh, okay. All right. Very good. Good job,
I
guys.
Yeah.
Yeah, I'm gonna see what your other group is doing. Hey guys, you want to check your first couple
Yeah.
scores there?
Which one? Just the cell A4?
Let me check. I was comparing your answers earlier.
Or which one is the problem?
So let's see. Looks like I'm not seeing anything in B4. Just a decimal point is all I see.
Oh, okay. Oh, decimal point. All right, we'll fix that.
And then check your calculations for, okay, let me go back and check this. You've got, those numbers are looking really large, like the 10 and the 8 and the 6.
Oh, yeah, okay. Let me go ahead and fix that then.
And it looks like you're missing a decimal somewhere also, like your decimal position is incorrect in those other z-scores because those numbers look good, but your decimals are off. So just check your calculations one more time, okay?
Okay, I'll run them back.
All righty.
So just while you're here, it would basically be, what is it? 15 minus, what is it? 14.997 or,
No, the
I'm
other
sorry.
way around. The
it would be
data value.
14,997 minus the mean of 15 divided by 0.1.
Yeah, so do the subtraction first and then divide.
Okay.
But yeah, keep in mind the data value always goes first and then minus the mean.
Minus the mean 15.
Was it negative 0.267?
Is
Is that
that,
what you're get- is that what you're getting?
I got 0.003. That was with the data entry first subtracted by the mean.
Okay.
And then honestly, just run back over through all of them.
Okay, guys, I will give you maybe another 2 minutes to wrap it up, and so that way we can bring everybody back together. Hey, guys, how are we looking?
We just finished.
Okay. Just check your sample 3, the first z-score for 14.993. Because remember, as I said, since that's a number smaller than the mean, it should be negative and you are getting a positive value for that. So just quickly check your calculation and I'll give you guys about a minute and then I'm going to bring everybody back, okay?
We did it.
Is it right before you?
Yeah, I checked your answer. It's right.
Okay, thank you.
We did it, guys. Congrats.
Yeah, those numbers look good. All right, great job, guys.
Okay, thank you.
Waiting for the other group to join us. So just as you are looking at your z-scores, just based on that criteria that they gave us about, nothing smaller than 14.9 pounds, how are you guys feeling about those 15 sample balls that you guys did the z-scores for?
I feel good about it.
Would you include all of them, or is there any part of your sample you would, not include in the shipment?
I think for our group, technically, they would all be in the shipment because I think it would have to be 14.90 and below, if I'm not mistaken. I don't know if I'm reading the word problem right because some of these are like 14.993. So if you round it, it rounds to 15, I
Yeah,
don't
but
know.
you want to round it to, 14 point, like you said, 14.90. So anything which would be less than 14.90 would be too small, but anything which is greater than that, would be safe to include in the shipment.
Okay.
And then, I would, again, if you had to go on the heavier side of 15, if you're using that 0.1 as your standard deviation, then that means the upper limit would be 15.1 then, right? So anything heavier than 15.1 would be too heavy to include in the shipment. So again, based on that, is any of your sample too heavy to be included?
For our group, I think the heaviest ball was 15.030. So I think that still rounds down to 15.
Yeah,
Um,
because you're not quite at 15.1 in that one either, are you? Jacob and Crystal, same question to you guys. Looking at your Z-score, do you find any of your balls that are too small or too big to be included? Oh, you guys did not do the sample 2, the first 5?
I thought we were sample 1.
Yeah, sample 1 and the first 5.
Let me do
are
those real quick.
Sample 2, because I gave you
Okay.
guys 15 and 15 since we only had 2 groups today.
Okay, well, let's do those real quick.
Okay. So I'll give you a minute to finish those and then kind of tell me based on your Z-scores, what do you think about your samples?
Okay. So it should be entered.
Alrighty. So would you consider any of your 15 balls in your sample that could not be included in the shipment?
Thank
Um,
you.
I guess, wouldn't it be 11 or 11, 12, and 13?
11, 12, and 13.
Oh,
Okay,
I'm
so the
sorry.
0.60,
0.60,
0.80, and
0.80,
Yeah.
1.00. Okay. So basically, if we are keeping that mean at 15 pounds and we know anything below 14.9 pounds cannot be included. So as far as your 14.9 goes, you are well above that, right? Because you've got 14.997 or 998. So you're not at that 14.900 or below that. So those numbers look good. Now, if you use your standard deviation for the higher end, then that puts you at 15.1. So we would assume that anything which is greater than 15.1 could not be included in the shipment either. So in that sense, guys, I would say your 15, of course, 15.005, 15.06, 08 are actually all within that standard deviation range. It's
I see.
this guy here, definitely the 15.1, because you are right at that threshold mark. So definitely that one would not be included in the shipment. And then just looking at the first 5 from your sample 2, again, it looks like you are doing really well with the Z-scores because you are not, one standard deviation away from the mean. So this guy really is the only one, the one in row 13, which does not meet the mark, right? So it's kind of amazing if you think about it, out of 30 samples that we have a total of, one ball has made it to that threshold mark where we wouldn't want to include it. So that kind of gives you an idea that, you know, if they were to produce exactly 10,000 balls, that would not be a great idea, right? Because some of them can end up becoming too heavy, and potentially some of them could end up becoming too light, but we don't have evidence of that from our sample. So we definitely be more concerned about the balls getting a little bit too heavy. So that would be one thing, you know, they would have to kind of look out for in that sample of 10,000 balls. Now, as far as to try and compare this with a normal curve, the way this works is, and I've actually put some notes in here. So we have to actually create this normal distribution table before we can draw our normal curve. So this one here actually has to be your mean minus the 3 times standard deviation, because remember that gives us our lower limit. Where did that graph go? I was showing you earlier. So right over here, this is kind of what we have to do, because we have to tell the table what this number would be when you are 3 standard deviations below the mean, and we have to do what is 3 standard deviations above the mean. So that calculation is where, and I'm just going to let Google Sheets do the calculation for us. So that would be the mean 15 minus 3 times the standard deviation. So that will tell us what the lower limit should be. And I'm actually going to do the same calculation here, but this is going to be mean plus 3 times. So that will give us the upper limit. So same thing we can do, equal to mean plus 3 times the standard deviation. So it actually tells you that for us to create the normal curve, this has to be our lowest point and the highest point has to be 15.30. Now, this can get a little tricky, you know, trying to fill in the table in the middle. So since we are at 2 decimal places, I kind of use that as a guidance over here. So what I did was I took our number from the previous cell, so that 14.70, and I actually just added 0.05. So doing it in increments of 0.05. And I believe that should give us enough to get us all the way to 15.30. So I'm just going to use the autofill to help us calculate that, and you will see that works out well for us. So, but you know, this will keep changing depending on what data you are looking at. If you were trying to create, you know, a normal curve in Google or Excel. So right now we did increments of 0.05, but you can do increments of 1, 2 if you have whole numbers. You know, it will just depend on what data set you are looking at. So this is something you have to do. So you start with, you know, 3 times the standard deviation below the mean, and you have to end up at 3 times the standard deviation above the mean, and then you can fill in the middle based on what your numbers look like. Now, this normal distribution that we have to do, this is actually a built-in function that you have in both Excel and Google Sheets. So it's actually that same thing that I have on the column heading, norm.distribution, and then you open your parentheses. Now, the way this works, and I thought I had included the function information here, but maybe it got lost somewhere. So the way you do this is the first value is actually going to be the data value, you know, this standard deviation value that we calculated here, comma, then you have to use the mean. And since I'm going to use the same formula for, you know, all the spaces in the table, I'm actually going to put dollar symbols around my cell because, you know, of course, our mean does not change. It will stay the same in that cell. So I'm going to put dollar symbols around it. Our standard deviation. And again, since the standard deviation stays the same, I'm also going to put dollar symbols around that cell. And then the last parameter is false. And, you know, by default, it always stays false. So you actually have to do this little function formula over here. And you can just do the autofill. We don't need that. So this is actually what you need to be able to create your curve, normal curve. And then once you have this table completed, it's actually very easy to do that. Just select all of these values from your table, and then you guys have insert chart over here. Kind of looks like a bar graph, or you can also go under the insert menu and you can go under the chart option from there. So, wherever you guys are comfortable with. And then it's actually picked a line chart, but let me see if it can let us do a little bit of a smoother line than that. There you go. So I actually selected the smooth line chart over here. So, it looks more like a curve instead of, broken up lines. So as you would expect, let's see if we can move this guy a little bit down here. So, kind of like I was showing you on the handout earlier. So you can see right here in the middle, we have our mean at 15 pounds. And then the acceptable weight range you can see is the 14.9 to the 15.1. And remember, as we were talking about the percentages, so you can imagine that 68% of the balls that are being manufactured are going to fall within that acceptable range, right? So if you were this manufacturing company, then you would have to think about, okay, so 68% of my product is going to be well within range, which means how much will my production need to be either to come up with those 15-pound balls, or how can I improve my accuracy? So is there something they can do in the production process that would, help them increase their accuracy? But basically the idea is that, if they wanted to stay within this weight range, if they follow the normal curve, then that means 68% of their production will be within that weight range. And then you can imagine the rest of it is going to fall outside of it. So you can see this will be now, 2 standard deviations. So 2 standard deviation leads us into 95% of our production. But, of course, anything that's within this weight range is not going to be acceptable for us, or even over here. So it's just kind of interesting how, you can kind of use this to even visualize what your data set is going to end up looking like. Of course, you have the Z-score, so they tell you if you are going to stay well within your range or not. Now, one thing to think about is, if your standard deviation is 0.1, then remember this is 1 standard deviation, away from the mean. So this is, that 14.9 is right over here, which is 1 standard deviation below the mean. And this is 1 standard deviation away above the mean. So that means as long as your Z-scores are less than, +1, or if they are, well, on the negative side, if they are greater than -1, your numbers are going to be okay. So you can see all of these numbers, are, well, on the negative side, I'm saying greater than, but, obviously they are still going to be a number less than -1. So as long as it's a number between 0 and -1, those are acceptable. On the positive side, if the number is between 0 and 1, that's acceptable. So as we were discussing, this guy is out because he's right at 1, which means you're too heavy of a ball to be included in the shipment. Now, if you look at our sample 2, all of these numbers are, between -1 and +1. So all of these numbers were acceptable. And then our sample 3, again, all the numbers are between -1 and +1. So they are within 1 standard deviation. So all of those samples were really good, with the exception of that one, 15.1 pound ball. So that's kind of how you can see we are able to use this concept of Z-scores and the normal curve to kind of help us visualize, but also come to a decision. If we were the manufacturing company, well, what would we need to do to make sure our shipment is going to be accurate, because obviously if you are going to be sending a shipment, you don't want to have even a part of your shipment being inappropriate sizes, right? Because if the client has asked you for 15-pound balls, you want to give them that. So just a simple example to just kind of show you how these calculations come into play. You actually have some really interesting examples in your homework assignments also, where they kind of pick different examples from, everyday lot, where you can kind of see, oh my God, normal distribution really does come into play in a lot of everyday things that we would not even think about. Any kind of production that you are doing, manufacturing, actually follows the same idea. So think about, just edibles, like your bags of chips, soda bottles, or even bottled water, those kind of things, because they all want to have that, if it's a 20-ounce bottle, they don't want to give you 22 ounces in a 20-ounce bottle, because then they're losing money. Think about gas stations. If you are at the gas station and you're pumping, let's say you're pumping exactly 5 gallons of gas. Do you want to get 5 gallons of gas, or are you okay with 4.95 gallons, right? So they have to make sure when it says 5 gallons, you are actually getting as close to 5 gallons as possible. So normal distribution actually comes into play in a lot of these different types of scenarios. So any kind of thoughts on this example here, guys? Lola, you're on silent.
Sorry, I had a question about the chart.
Yes.
So I'm trying to pull up because you're not sharing your screen anymore.
Okay.
Give me 1 second.
Uh,
Okay, I have it.
okay.
So the bowling, the one that we were working on, the bowling balls activity, how you did that chart, and can you see like where I'm like highlighting it?
Okay, hold on.
Okay.
Yeah, right here.
So
at
like
the
this
weight.
is the information that you used to create the line, the smooth line chart. I see that it only has 13 values on it as far as weight goes. Am I counting that right? 1, 2, 3.
Yeah, probably.
So I was just wondering, because I know like if you go over here to sample 1, sample 2, and sample 3, like there's like 30 samples, I think.
Yeah, but you will notice that we actually did not use those numbers to
Okay.
come up
Oh,
with our weight table, because those numbers, are getting into the finer measurements. We are
okay.
just trying to create, what those 1, 2, and 3 standard deviations would look like on a
Okay.
normal distribution curve. So that's why we kind of start out with, the 3 standard deviations below the mean, which is at 14.70, and then 3 standard deviations above the mean, which is at 15.30. And then these numbers, we just added 0.05 to kind of fill in those gaps. So
Oh,
as you
okay.
can see, all the numbers that we actually have in the sample are falling right actually between these 5 numbers over here. So as far as our table is concerned, we don't have any weights which are less than 14.90, or any weights which are, larger than 14.10. So yeah, and that's kind of why I had you guys do the z-scores first, because the z-score kind of tells us where they would fall on the normal curve, but to draw the curve itself, you actually have to use a different calculation.
Okay. And then my only other question is, when you use the spreadsheet formula for normal distribution, can you remind me why you do the dollar signs and then why you add false?
So what happens is with the dollar sign, because my mean is in this cell only, right? And my standard deviation is here only. So as I make my autofill happen, if I don't use that dollar sign, then your Excel by default will start using the cells underneath that. So if you used cell E3 here, and when I did the autofill, this guy would want to use cell E4, E5, E6, because it goes down in order. And I wanted to keep my mean is only at 15. So the other thing you could have done, instead of using the dollar symbol here with the mean, you could have actually typed in 15. And then you could have, for the standard deviation, you could have typed in 0.1 also.
Okay.
And it would have given you the same
Same.
measurement. But because, I just let Excel pick the number, the cell for me, I just use it with the cell. And because I want to keep that same cell for all the calculations, because you will see how automatically that $E3 and $E4 stayed with the dollar symbol. So each line knows that my mean and standard deviation are in those two boxes. And the
Okay.
false is, I am entirely not sure why the false is, because when I did, I basically did a Google search to see how I would draw the normal curve. And in that, everybody had the parameter of false in that last one. So I'm not entirely sure what the true and false does. Because I haven't actually found a description for normal distribution where they give you breakdown of each formula. So yeah, I'm not sure why the false is there, but the first number has to be your data set, the weights over here. The second number has to be the mean. The third number has to be the standard deviation, and then you put false in the fourth one.
Okay. Yeah.
Okay.
Thank you.
Any other questions, Lola? Okay, did anybody else have any questions on this? So just as a final reminder, I wanted to let you guys know that because we are actually starting to get into chapters which have a little bit more, content, the assignments are a little bit bigger. You are not going to have any weekly discussions or assignments for this week. So there's no discussion prompt and there is no assignment that you guys normally turn in on Saturday for this week. So you are actually working on your My Stat Lab assignment. So you will actually have 5 sections of homework and then your quizzes and the exam. And the way I've done the quizzes, as you would have noticed in the previous week, there's 1 quiz for chapter 7 and 1 quiz for chapter 8. So instead of kind of putting them all together, I separate your quizzes by chapter. So that way, it kind of makes it easier for you to keep track of. And then the exam is, of course, combined for both the chapters. So any questions before I let you guys go? All right, so again, don't forget to request your password as you move forward into 7 and 8. And if you have any questions, please feel free to reach out to me. If you need additional help, don't hesitate to ask for help, okay? All right, guys, have a wonderful day. Good luck, everyone, and I will see you on Monday next week.
Actually, one more quick question. I'm sorry.
Sure, no problem.
Is there any way to like reopen like a locked quiz, or once the due date goes, that's it? There's no additional
So remember, I have offered you guys an extension, a one-time extension. So if you are interested in finishing up something you missed, send me which assignment it is and I will open it up for you.
Okay, sweet. Yeah, it's just a terminology quiz. I totally spaced it. So yeah.
Yeah, so
I'll
just
send you it.
email me which quiz it is and I'll open it up for you.
Sounds good. Thank you.
All righty. All right, guys, if you have no other questions, then I'll see you next week, okay? Be careful, everyone. Take care. Bye, guys. Be careful.